Hi, this is Mrs. Blake, and today we're going to talk about double replacement chemical reactions. The materials needed for this video are a periodic table with a list of common polyatomic ions so you can write your chemical formulas correctly. Double replacement, or sometimes referred to as double displacement reactions, are where positive ions switch partners during the course of a chemical reaction. Any ionic compound is going to be made up of a positively charged ion paired with a negatively charged ion, and the positively charged ion is always going to be in front. So in these chemical reactions, your positives are going to switch spots. So if you look at the example equation, we have A, and A is in front, so A is going to be positive, paired with X, and positives are paired with negatives, so X must be negative. B is in front, so that must be positive. Y is in second position, that must make it negative. And in these chemical reactions, A and B switch partners. One of the most important things when A and B switch partners is that A and B are in front and they have to stay in front. So if you look at the products that are created, A is in front and B is in front. The difference is that A is now paired with Y and B is now paired with X. So positive is always first, positive is always paired with negative, and if you're not sure, look at your periodic table to identify whether it's a positive or it's a negative ion. The second thing is you have to write a new chemical formula. Just because there may be a subscript of a 2 over here by my X does not guarantee that there will be a 2 when it is paired with B. So it's really important that you pay attention to the chemical formulas and write new chemical formulas every time you predict new products. Now, why do these chemical reactions happen? Well, it's because ionic compounds dissociate or break apart in water. And so if it's an ionic compound that breaks apart, and let's take a look at an example here. So Na is pretty happily paired with CO3. But if you place them in water, water has the ability to pull those Na pieces away from the CO3 pieces. And once they are separated away from their negative ion, they have the ability to react with anything they come in contact with. Now these are ions. So when I look at my periodic table, sodium's in group 1, which means it's going to be a 1 plus charge. And carbonate is a polyatomic, and its charge is going to be a 2 minus charge. Second thing, when they dissociate or break apart, is they do have to break apart into an equal number of pieces. So if there's 2 in the compound, there has to be 2 sodiums when they break apart. So it's going to break apart into a 2-to-1 ratio. And calcium and chlorine are also aqueous and will break apart in water. And that means it's going to break apart into calcium pieces and into chlorine pieces. But there's going to be 2 chlorine pieces for every 1 calcium piece. And calcium is going to have a 2 plus charge. Being group 17, chlorine is going to have a 1 minus, or can be just written as a minus charge. And now they're free to interact with other things. So when I mix these 2 beakers together, sodium could interact with carbonate, but sodium could also act with chlorine. And when we take a look, that's where new products are going to form. So when these 2 containers are going to be dumped together, I have sodium pieces that are going to be free to interact. Now, positive and positive are going to repel. So the only way this can react is when a positive is going to react with a negative. In a double replacement reaction, a positive forms a new partnership. So sodium was with carbonate, but sodium can now react with chlorine to form a new partnership in that reaction. And I had calcium, and calcium was a 2 plus charge, and calcium was with chlorine, and sure, they could form again, but it could also form a relationship with carbonate. And when calcium and chlorine form together, they're going to form a solid, what we know as precipitate. And that precipitate gives us the name precipitation reaction in this chemical reaction. So when I'm taking a look at predicting my products then, I'm going to start with Na2CO3. And it is going to be reacting with CaCl2. And in this reaction, I know that sodium is my positive and calcium is my positive. And what happens in this reaction is they are going to switch my partners. So when I am going to predict the products, and this is very much what your equation looks like, it's kind of blank on the other side. I am going to take sodium and I'm going to put it in front with chlorine. So I have sodium, and sodium is paired with chlorine. Key rule: don't steal subscripts. What do I mean by don't steal subscripts? Well, formulas change because sodium has a different charge than calcium. Sodium and chlorine do not necessarily form in the same ratios. So while this sodium is paired with it is a 2, I cannot bring that 2 over here to be able to make my reaction. And while this chlorine has a 2, I also can't. I need to go to my periodic table and I need to be able to find my charges, because sodium and chlorine make a new formula. So my periodic table says that sodium is going to be a 1 plus charge. And I look under group 17, where it's chlorine, it's going to be a 1 minus charge. And plus 1 and minus 1 means that there's not going to be subscripts for the sodium and this chlorine. And then again, following the rules that your positive has to be first, calcium is going to come over here and sit where sodium is. So this time it's going to be calcium, and nope, I cannot steal that subscript. That stays there. Now, polyatomics do stay as polyatomics. Carbonate is CO3. If it's polyatomic, if it has an added subscript, remember, it has to be outside the parentheses. And since there's no parentheses, carbonate is just going to be CO3. Again, I use my periodic table. Calcium is group 2, and it's going to be a +2 charge. And carbonate is going to be a polyatomic with a 2 minus charge. And when they're both +2 and -2, they cancel each other out. So the formula is just going to be CaCO3. Once I have my formulas written, then I need to make sure that I'm going to balance my chemical reaction. If I cannot balance the reaction, I probably have a subscript wrong for my chemical formulas, and go back and double check your subscripts. So here I have 2 sodiums, so I need to put a 2 as a coefficient in front to give me 2 sodiums. And I have 1 carbonate, 1 carbonate, 1 calcium, 1 calcium. There's 2 chlorine, but the 2 coefficient gives me 2 chlorine, and it is a balanced reaction. So let's take a look at another couple of examples. So I have potassium carbonate reacting with barium chloride, and it's my job to predict the products. Again, I need to identify what is my positive. In this case, potassium is my positive. I need to identify my positive, and barium is going to be my positive. And those positive ions are going to swap partners. And that means potassium is going to have a new relationship, and it is going to pair with chlorine. And I'm not writing formulas yet, I'm just pairing up. And then my next product, barium, is going to come and sit with carbonate. Again, I cannot steal the subscript that's by potassium. And carbonate's going to be CO3. So I'm going to use my periodic table, and I'm going to find my charges. And potassium is group 1, so it's a 1 plus charge. Chlorine is group 17, and that means it's a 1 minus charge. So +1 -1, this is just going to be KCl. And barium on my periodic table is going to be an alkaline earth metal. That makes it a 2 plus charge. And carbonate's a polyatomic that I'm going to look up on the back of my periodic table and find on my polyatomic list that it's a 2 minus. But again, if it is a 2 plus and it is a 2 minus, those like charges are going to simplify and they will cancel out, and it just stays as BaCO3. So once I have my formulas written, then I need to balance my equation. I've got 2 potassiums, so I put a coefficient of a 2 in front, and there's going to be 2 potassiums. I have one carbonate and one carbonate. I've got one barium and one barium, and here's 2 chlorine, but again, the coefficient in front of the KCl gives me 2 chlorine, and it's a balanced equation. Let's take a look at another one. I've got cadmium nitrate reacting with ammonium sulfide. Again, positive and positive. Ammonium is a positive polyatomic, and that means I will take the entire polyatomic of NH4. And with most polyatomics, it is going to be in parentheses, and here's the subscript that I'm going to leave behind. I just use that for balancing purposes. So I am going to switch spots, and cadmium is going to come, and cadmium is going to be paired with sulfur. And then I am going to take NH4. And again, I'm not interested in what's outside the polyatomics. So I'm not looking at the parentheses, NH4 and NO3. And your positive always goes first, and NH4 is going to be my positive. So NH4 is going to be paired with NO3. So my positives are in front, and now I need to write my formulas. Well, according to my periodic table, cadmium is going to be a 2 plus. And according to my periodic table, group 16, sulfur, is going to be a 2 minus. So a 2 plus and a 2 minus, they're going to cancel each other out, and cadmium sulfide is just going to be Cd with a capital S. Polyatomics, NH4 ammonium has a 1 plus charge, and NO3 has a 1 minus charge. And again, it's a 1 plus and a 1 minus, so I don't have to worry about subscripts, and that means neither the NH4 nor the NO3 goes in parentheses in this chemical formula. Now I need to balance the reaction, and I have 1 piece of cadmium and 1 piece of cadmium, but I have 2 nitrates, so I'm going to put a coefficient of a 2 in front of my nitrate, and that means I've got 2 ammonium, but that gives me 2 ammonium, and I've got 1 sulfur and 1 sulfur, and it's a balanced reaction. Calcium is my positive in the next one. Hydrogen is my positive in my second one. And so when I'm taking a look, my calcium and my hydrogen are going to switch spots. Again, with the polyatomic, I keep the polyatomic together. I do not take anything that is outside of parentheses. So I do have to take the PO4, but I'm going to leave the 2 behind because it's outside the parentheses. So in this case, calcium is going to form a compound with phosphate, and hydrogen is going to form a compound with OH. Remember, your positives have to stay in front. So calcium's my positive and hydrogen's my positive, and they're always going to be in front. Have to have pairs that are positive and negative. So calcium, according to my periodic table, is going to be a 2 plus. And according to my polyatomic list, phosphate is going to be a 3 minus. And that means I do need to do something with this chemical formula. So you can equal out your charges or you can cross your charges either way. But I am going to end up with a 2 on my phosphate, and that means phosphate needs to go in parentheses before I write the 2 subscript. And calcium is going to get phosphates 3. So it is going to be, and I'm going to rewrite this a little bit, it is going to be Ca3, PO4, 2, and that's going to be the formula for my calcium phosphate. Well, hydrogen, according to my periodic table, is going to be a 1 plus, and hydroxide is going to be a 1 minus. And so this can remain as HOH, but some of you may have picked up on the fact that this is actually H2O and could be rewritten as H2O as well. So I do need to balance this reaction. So I've got 3 calcium, and so I'm going to need a 3 over here in front of my calcium. That gives me 6 hydroxides, so I need to put a 6 in front of here for 6 hydroxides. That gives me 6 hydrogens, so I need to put a 2 times 3 gives me 6. That gives me 2 phosphates. So in a chemical reaction for double replacement, your positive ions are going to switch spots. That means that they are always going to be in front. They always need to be paired with a negative. Make sure you're using your periodic table to check your charges and write new chemical formulas. And that's how you predict the products of a double replacement reaction. Have a good day.